Hello, hello. Am I audible, guys? Am I audible? Let's see if I'm audible. Am I audible, guys? Perfect. So, hi, guys. My name is Prashant Jain. I am graduate from IIT Bombay, and these are the learners who have actually studied from me and went on to represent, went on to study IIT, went on to study BTech in different IITs. This is the result which we have this year for JEE. We have got 14 ranks in top 100. So yeah, if you want to enroll for the Ramanujan batch, which is the live English, live IOQM course, is being taught by me every Tuesday and Thursday. Amazing. The link is in the description, right? The link is in the description. So now this year we have the target of 1,000 learners. So we will get 1,000. This get 1,000. Right? Okay. So let's get going, guys. Let's get going. So see what is Chinese remainder theorem, right? The title you must have studied. You must have seen Chinese remainder. What is the meaning of this theorem? What is the meaning of this theorem? How does it help? Okay, so let's talk about it. Let's talk about it, guys. So first of all, I'll start with a very simple problem. You have to answer this. Find minimum value of mod x plus mod y such that 13x plus 17y equal to xy belongs to integer. Let's try to solve this. Can we solve this one? So the solution of this problem is done by something called Bezout lemma. Bezout lemma. I'm going to give you some time to solve it. But what does it say? Let me speak out loud. If HCF of A and B is H, if HCF of A and B is H, then there exists PQ belongs to integer such that AP plus BQ equal to. This is what we call Bezout lemma. A times P plus B times Q is equal to, right? Now, what is so unique about this lemma? What is so unique about this lemma? Just to make you understand, let's assume that let me take two numbers 4 and 8. Can I say that their HCM is 4, their HCF is 4, right? So what this is saying is that you cannot have two integers P and Q. You will have no solution, and it will have no solution because this whole thing is divisible by H. This whole thing is divisible by H. HCF. HCF of 4 and 8 is 4. So HCF will divide the left hand part, it will divide the right hand part. That is why we can find two integers P and Q's. This whole thing actually becomes equal. This is the important. This is the important thing, right? Are you getting my point, guys? Are you getting my point? Yes. Perfect. Now let's move on. Let's solve this one. So if you see, 13 and 17 are co-prime. They are prime also, but they are co-prime. Co-prime means their HCF is 1. HCF of 13 and 17 is 1. Right? So in when we were kids, how we used to calculate the HCF? I think this is how we used to calculate the HCF. If you remember, in last you have this as your HCF, right? So if I write these things, if I write this division in terms of Euclid division lemma, then can I get this 17 is 30 times 1, and then this becomes my dividend, and 4 becomes my divisor. So I'm getting 4 times 3. Okay. Similarly, in the end, I have 4. This is my. Now just see here. Just see here. In my equation, I want 13, I want 17, and I want was my. So I'm just circling them, whatever I require. I require 7. I require. I require. So 4 is something which I have to do away with, right? So I'm writing in this equation. I want 13, right? I'm writing this 1. In fact, this 4, right? I'll just simply replace it. I'll just simply replace by anyway. See, like I have, in fact, I can. This is what I want. I can simply have 4, the value of 4 coming from here. Can you see? I write 4 like this: 13 minus 1 upon 3. If I put this value of 4, what do I get? 17 is equal to times 1 plus 13 minus 1. Now let's multiply 3 everywhere. Can you see this? Can you see this? Then the equation. You see properly, if you compare this and this, you can see that my x is 4, y is minus 3. This value is minimum. This value is minimum. Bezout lemma always gives the minimum value of mod x. This is how to evaluate it. This is how to evaluate it. So to find first solution of this equation, we use a mechanism like this. This is called Bezout lemma. The mechanism is Euclid algorithm, more than like finding the HCF, and we are just back substitute. 13x plus 17y equal to 1. One solution is x equal to y equals minus 3. So if you remember, if you have studied my basic lecture, then if my first solution is this, to get the next solution, I have to add 13 here and subtract 17 here. Right? Again, add 13 here, subtract 17 here, and so on. Right? Just verify. What is, so I am saying 13. This is also a solution. Let's verify this. 13 times minus 30 plus 17 times 1. Yes, this is indeed coming out to be. This is indeed coming out to be 1. Right? 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 Girish Jain said that, sir, I got 7. Got 7 as answer. So this is the mechanism. Can you write, everybody? Can you write UDAN if you have understood? If you have understood it, please write UDAN, understood, done and noted. Understood, done and noted. Please. This ISI will be covered. So that I have understood it properly, I have understood. Let's do one more problem. Any prime number 23x plus, let's say 37. Let's try to solve. Let's try to solve this. 23x plus 37y equals 1. Right? You can pause the video and you can solve it. But, and like after that, you can see my solution. Let me do it. Again, similar mechanism, 23 times 1. Then this becomes my dividend. This becomes my divisor. Then 15. 9 times 1. 5. 9. 5 times 1. 4. 5. 4 times 1. My HCF. My HCF. What do I need in my equation? Let's circle them. Let's circle. I need 27. I need 20. Like just from here. I need to remove this 40. Remove this 40. I have to go till here. Because see, like I can remove this 14 from here. But then will come. To remove 9, 5 will come. To remove 5, 4 will come. Finally. Right? So let's write 9 as 5 minus. This gives me this 4 as 5 minus. This gives me 5 times 2. This equation is helping me. 5 becomes, right? Now let's see the value of 14 times 1. 5 becomes, okay. From this equation, you get the value of 1 times 2 times 3. 9 becomes the value of, replace the value of 9. Okay. So let's write it down. 23, 14 times 1, 14 times 2 plus 1, 20, 14 times 5. From here, we are getting 23 times 3 plus 1 upon 5, because 14 was the last value we needed to get removed. Let's write it down here now. You can see finding like this is much more lengthier, but then Chinese remainder theorem is a concept which is largely oriented to RMO and INMO. Right? You will not find very difficult problems from it in IOQM, but it is very, very important concept, RMO, and right? That is why we need, and like you can see from the calculation that it is getting very lengthier, right? Right? Okay. So now, when I replace the value of 14, this is the value of 14 in this. Let's see, what do I get? 37 equals 23 times 1 plus, what was my 14? 23 times 3 plus 1 on 5. Yes. Now I'm multiplying 5. 5 equals plus 1. Right? At plus 8 plus 7 5 1. Pairing this equation with this, x equals minus y equals, Just to confirm, 37 times 5. 37, if you see what is 37 times 5? 37 times 5 is 185. 23 times 8 is 184. Right? That's it. X equals -8, Y equals 5. Anonymous person. Got it. Are we clear about it, guys? Are we clear about it? You can write done. So you can move. You can move. Right? Now after this, we can actually write the statement of, you can write this statement. Let us write. What does CRT say? If n is congruent to remainder 1, mod divisor 1, n is congruent to R2, mod D2, and so on till I have Rn, mod Dn, and then there is a condition. The i's are pairwise co-prime. What do I mean by pairwise co-prime? If I take any combination of these divisors, let's say D2 and D4, let's say D3 and D6, let's say D1 and Dn, all the pairs are co-prime. This is the condition. Then n will have a solution R congruent to mod L, where L is LCM of D1, D2. Okay, this is the statement of CR. It says that it says about the existing, does not help us finding. How do we find the solution? How do we find this R? We find this R using. So let me show you with an example. This statement, this whole statement looks very strange, but when we see it using certain values, you will be able to understand. So let me give you an example using very small divisors, right? Very small divisors I am going. Okay. So let's say example n is congruent. Okay. And n, by the way, this is called simultaneous congruence. Called simultaneous. This is called simultaneous congruence. Okay. Okay. Just hear me out. Okay. N is congruent to 2. N is congruent. And then n is congruent. Let me take one. In fact, let me simply solve this for you. Right? So if I write all the numbers which leaves 2 as remainder upon, I can write them. If I write n congruent to 3 mod 30, right, like, right? So what I'm trying to say here is, let's find the common number between, let's find a common number which satisfies both. Common number which satisfies both. You will see that n equals 40 solves it. Right? I will tell you how to solve. I will tell you how to solve. We will study. But n equals 42 solves it. You can see 42 leaves 2 as remainder upon division by 5. 42 leaves 3 as remainder upon division. Great. What is the next number? What is the next number? If you add m of 5 and simply add 60. Right? If you add 65 here, get 1 not. Now check for 107. Is it satisfying both? Yes, obviously it will satisfy. So why it will satisfy? So 42 plus 65, right? I'm writing 42 as 13 times q plus 3. If I'm adding 65 here, I'm adding actually multiple of 3. So this becomes 13q1 plus remainders remain intact. If I'm adding multiple of 13, my remainder will remain intact, mod 13. If I'm adding 65, it is also multiple of 5, which means that the remainder mod 5 will also remain intact. So these remainders will remain intact if I add LCM or any multiple of LCM, right? 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 Hence, that is why we have this solution of this. This is what C is saying. There exists a R here. Mod L. L was LCM of these all these numbers, all these divisors. LCM of 5 and 13 here is 65. If I take 65 LCM, then I am getting the solution for 65. The answer is. Are you clear about the statement of CRT? This was just to let you know the statement of CRT. Then, with the help of another problem, can I do number theory before sequence? I think yes. Number theory is great, literally very, very great. I really like number. Number theory is something very amazing. Sir, R can only be found by that AP method. So, like, this is very interesting. Some students who have studied AP are saying, like, find also part of G. This is what I tell, that JEE concepts are very, very much related. IOQM preparation must for all the JEE aspirants, right? This concept is asked in JEE, finding common terms of AP. Okay, okay, yes, yes. So let's solve it. Let's solve. If you want to solve, give me the solution of this. Right? Give me the solution of n congruent to 1 mod 5 n 3 mod 7. Let's solve this. Let's solve this, guys. Right? You can pause the video and solve this question. And I think by the time. Now, how I solve it? Let me tell you how I solve it. First of all, these two are very small. Right? I will try to combine these. I'll simply write that n is 5p plus 1, and it is also, which means I have to solve. Right? 5p. Now this is Bezout. This is Bezout. HCF or any multiple. By observation, 5 times 3, 5 times 6, 7. Can you see it? Because these are small divisors, we can apply our number sense and get the answer. We can apply our number sense. Okay. This means I can choose P as n becomes 6. This becomes obviously Q 6. Sorry, 31. So solution of these two, n congruent 31 mod LCM of these two, 35. Now I have come. Now I have to solve these. Will how mod 17. This is 17 1 plus 35 Q1 1. This gives me 17 minus 35. Again, it is to be solved using Bezout lemma. Okay, it is to be solved. But if you see here, find one. You can see Q1 becomes 3, Q1 becomes 4, 1. How you get answers. And size if P1, if I'm putting P1 equals 3, my N is 20 mod. What is 35 times 17? Or rather, 35, 5 is my answer. Right? You can add, like, not satisfied. Getting what you, if else between 5 and then you get n 0. Interesting. All these, you can apply these smart methods. I agree. But it is very difficult. Obviously, it is difficult. We are talking about RMO INMO concept. We are not talking about IOQM here. IOQM is long gone. IOQM is done. Right? Sir, your voice fades away. My voice fades away in between. Sit. Sit. I don't think it should happen. Hello, 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 hello. Hello, 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 hello. Let me hold it here. Let me hold it here. It is happening because this mic is a bit loose. This mic is a bit loose. Let me. Is it okay now? Is it okay now? Now let me give you another method for it. Let me give you another method. And like this method is self-developed based on my JEE teaching, right? So n was congruent to 1 mod 5 and n is congruent to 3 mod 7. N was congruent to the mod 7. Right? Let's solve. Let's solve this. Okay. If I write all these numbers, right? Please see properly. This is 1 mod 5. But let me see what are the remainders of these numbers mod 7. I am writing mod 7 remainders here. I am writing mod 7 remainders here. Okay. Mod 7, if I write mod 7 remainders here, this is 1. This is 6. This becomes 4. This becomes 4. Mod 7 I am writing. 16 is 2. Now are you seeing it? 1, 6, 4, 2, then becomes 0. Then minus 2 is 5, 3. This is the number which has 3 as remainder. Are you seeing the pattern here? If you're not seeing the pattern, then 1, then it becomes 6, then decreasing by 2. Why it is decreasing? Please understand. 5 is minus 2 mod 7. That is why when we talk about mod 7, remainders are all you have to do is to adjust. Like 1 can be written as, right? Then 0 can be interpreted as 7. Mod 7, 0 can be represented as 7. Then 5, 3. And you needed 3. So please see 1, 2, 3, 4, 5, 6, 7. So seventh term of this AP will be same. What is seventh term of this AP? This AP is 5q minus 4. What is the seventh term? 5 into 7 minus 4 equals 30. So that is how you calculate. Okay. Okay. Yes, Chinese remainder theorem. The statement of Chinese remainder theorem is right. Hello. Right. Now let's see. I have 31. Now I'm writing PC. Now my congruences are 31, 5, n is congruent. 15 mod 7. Now always write the bigger congruence. Let's write this bigger congruence. So I'm writing 31 or 30, 31, 66. Now calculate remainder. Now adding 30, which means actually plus 1. 5 is congruent to 1 mod. 35 is congruent to 1 mod. So in terms of 7 mod 17, I'm simply adding 1. I'm simply adding 1. Okay. If I add 1, what is the remainder here? I have to add. I got lucky. 15 is okay. Okay. This is my number. You have to watch it twice or thrice to actually understand what is going on. Because this thought process may seem very complicated, but very intuitive. You have understanding of brief understanding of AP. You have understanding of AP, it will be very simple. That is it enough to watch your two. Vinayak edits. We are premiering lectures of my previous year IOQ, and you just have to follow. Right? Just follow that. We are taking care of it. Sir, why 14? Remainder of 30. You divide 17. When you divide 30 by 17, we are not generating this number. We are not generating this number. Okay. Okay. Is it clear? Is it clear? Guys, is my voice clear? The voice problem still persists. It is coming and going. Is it? It is coming and going. Hello, 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 hello. Hello, 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 hello. It should not be the case. It should not be the case. Voice should be very clear. Is it clear now? Is it clear now? Is it clear now? Is it clear now? Can you comment? Can you comment, please? Okay, perfect. Right. So let's see if you have understood it. Let's see if you have understood it. Let's solve this one. N congruent to. Okay. Let me write. Let me make question for you. Just a second. N is congruent to 1 mod 2. N is congruent to uh, N is congruent to 4, 5. N is congruent to 0 or about 7. Is it divisible by 7? N is solve this congruence. Sir, are we going to study about binary exponent? We are not going to study about it. Mohit, there is no such rule. There is no such rule that can we combine all the divisors. It is, see, like, it is your choice how to combine. So, for example, if I were to do it, if I were to do this, first of all, see, like, calculate the LCM. The LCM is coming out to be, the LCM is coming out to be 2310. So, obviously, my N is congruent to something mod 2310. And I have to evaluate this something, right? My choice of, see, like, the first step to do is to convert these 5 congruences to congruent, right? Do this first. Do this first. Do this first. Okay. So if I see these 3 gives me something mod 40. These 2 gives me mod. This is my choice. I will combine like this, right? I will combine like this. See, like the basic thing is close. These two numbers should be okay. Okay. Binomial theorem in number theory. Binomial theorem, obviously, I will be covering binomial theorem. Right? Okay. So let's combine. Let me write. See, very easy. One combined, and 7 is the first number. 7 is the first number. 7 is the first number. I can write n congruent. This satisfies first. So I have combined 1, 2, and 4. 1, 2, and 4 I have combined. Let's talk about 3 and 5. Let's talk about 3 and let's talk about 3 and right. 3 is 4 mod 5 is 2 mod 11. Like there is something very amazing about mod 5. 4 mod 5 will have 4 or 9 as last digit, right? That is the beauty of 5. So I will simply solve mod 11. Mod 11 is 5, 37, 49 is my smallest number, right? 49 is my smallest number, not 49 in fact. I had to add 11. Add 11, 4, right? 24 is my smallest number. This becomes 24 mod 5, right? Am I making sense here? Am I making sense here? Are these the two congruences? Are these the two congruences? Right? Right? Okay. So now my second step is to solve these two congruences. 24 mod 55. Right? I'm going to write down this here. 24, 79, so on. But I will write mod 42 here. What is 55 mod 42? Is actually 13. So my remainder here is 24. It is becoming 37 here. You can see plus 13. Plus 13 is the key, right? Plus, okay. Eventually, I need to have 7 here. Eventually, I need to have one. Can you see it? Can you see it? Now, this is, I'm adding, simply adding plus 30. It, 1, 4. What I'm doing here is, you'll just see the magic. Right? Right? So, here's our just recreating remainders here. Right? Right? One more. Right? Now, can you see 8, 5, 8, 5, 2? Right? Minus 3, minus 3, minus. Simply minus 3, minus 3. Right? Then minus 3. Now please see here. 7 is of the time it is required. Why it is required? Because we are subtracting everywhere. So I can see 3 series here: 24, 21, 8. Then another one is 37, 34, 30. Another one is 5. Right? This sequence is of the type, this will have 7. This will have 7 somewhere down the line. Now, what is this? If you see, this sequence is 12 times 3. So if you see this 11th term. Okay. Now, 11th term in this problem. 2 more, 34. We are going like this. Right? Then we will have 11th term. So if I see, if I take chunks of 3, I will have 30 terms. Then this one is 32nd term of this whole AP. If I talk about this AP, the 32nd term will leave 7 as remainder. I will solve it using Bezout lemma also, don't worry about it, right? So 32nd term. If I talk about the 32nd term, so this AP 5, 1. If you give me 30, what do I get? 0, 1, 7, 6, 1. Answer is 1, 7. So 1729. The answer becomes n congruent to 1, 7 mod 2310. 2310. Okay. Ramanujan Hardy number. That is how I make these questions. I take a very special number. Okay. Okay. Right? Let us solve. Let us solve Bezout. So see, like we got till here. Now let us solve using Bezout. In fact, this will be actually simpler. 42q plus 7 is equal to 55p plus 24. Right? It is like it was. Okay. Okay. Now I will solve. 42q minus 55p is equal to. Okay. Right? Let's solve this one. Yes. So again, I will write 55 as 42 times 1 plus 13. 42 is 13 times 3 plus 3. 13 is equal to 3 times 4 plus 1. That is how I have 1. I will replace this 13 by 13 minus, what was it? 13 minus 1. So this 42 becomes 13 times 7, 13 times 4 rather, times 12. 13 times 13. 68 times 4. Okay. Then do I need 42? Yes. Of course I need. Then 42 times 4 plus 1, 130. So 5, 42 times 1 plus of 13, 1 by 13. This becomes 55 times 13 equals 42 times. Gosh. So my solution is, you would say, sir, how do I get 17? How do I get 17? It's very simple. 42 times 7 minus 55 times 30. Right? Can you see? 42 times 7. I simply multiply with minus 70. So 42 times minus 289 minus 55 times minus 220, 70. So here I have it. I have the solution with me. Right? Now to get next solution, since fraction is here, just have to add 40. Right? So let me add 55 times 6 here. 330. Right? This becomes 330. So let me add 330. If I add 330 here, did not. Yes. That is my solution. That's it. I don't have to go further. Because I is found 42 times 41 plus 7 be my n. What is this? 41 times 2, 82. 41 times 4 is 164, 1722, 7, 179. Right? So there I have it. This is the answer. But it requires a lot of mental calculation. You have to be fast in calculation. Is it not? Right? 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 So you just have to solve for one and get the number. The process. It's a very difficult process to see it. But sir, what is the use of all this? The use of all this. So let me solve. Let me solve RMO 1990 problem, which asked find last three digits. Find last three digits 2 to the power 19. This was the question. Now my Euler-Totient function. Euler function gives 2 to the power 4. It does not help. Euler-Totient divisors and the dividend are co-prime. Okay. Okay. So how to solve it? How to solve it? Basically, last three digit are remainders mod 1000. Right? Remainder mod 1000. If you see, this is 8 times 125. So if I write n congruent to something mod 125 and n congruent to something mod 8, this will have a solution n congruent to something mod 1000. By CRT, I will have this solution. This will be my answer. This is the last three digits. N is 2 to the power 19. So what you need to help me here is very weak in calculation. So just find this for me. Can you tell me what is this? Can you tell me what is this? 2 to the power 1990. XDAC you will understand. Zero. Yes, obviously it is divisible by 8. Perfect. Help me here. Help me here. Help me here, guys. Mod 125. How to solve it? Now I'll solve this. I Euler-Totient. 2 to the power, this is 100. 2 to the power 100 is congruent to 1. Mod 120. Okay, this means 2 to the power 1000 is congruent to 1. Now, how to solve 2 to the power 199? How to solve 2 to the power 1990? I have a solution. I have a method here. Right? Let me help you out. See, 2 to the power 2000 can be written as 126. 2 to the power 1999 is 63, or it can be written as 188. 188. 188. Remove two powers. This becomes you divided by 47 becomes 25, and this is also divisible by 4. 1995 becomes 40. So we have reached till here, congruent to 43, which again gives 160. This is a jackpot. 168 is actually divisible by 8. So 1992, 146, 173, 198, 99, 2 to the power 1990 congruent to 99 mod 125. This is I have. This is what I have. Right? Right? 2 to the power 1990 is congruent to 99 mod 125. 99 or 44 or 24? 99 only. Is it 99 or something else? 99 or something? And have I done correctly? Have I done correctly? You need to verify, guys. Or 10. Four nine, 49, 5. 99 is correct. 99 is certainly correct. Okay. 99 is correct. If I see this becomes, then it next term is 220, right? And then check for mod 8. Check for mod 8. 224. Then add 250 to it because this is divisible by 4. But it is not. Oh, it is divisible by, it is 8 also. It is divisible by 8 also. This is divisible by 8. So 224 is your 224 is right. No, 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 no. 2 to the power 99 is not 1 mod. 2 to the power 100 is congruent to 1. 224 is the correct answer. Hindi classes are going on in recorded. Hindi classes are going on recorded form. Right? Check last power 19. 224 is correct. 224 is correct. 224 is correct. Checked it. Chat GPT as well. Right? Right? This concludes our Chinese remainder theorem. Right? This concludes our Chinese. I know it is a bit difficult, but this, can we move ahead now? Can we move ahead? Can we move ahead? Right? Perfect. Right? Now, write another theorem. Sn congruent to n. What? Sum of digits Sn congruent to n mod Sn congruent to n mod 9. Sn congruent to n mod 9. Okay. Okay. Sn congruent, right? Let's see the proof of it for 4-digit number. Can I write this 4-digit number as 1000A plus 100B plus 10C plus D? Now simply isolate the sum of digits. Can I write it like this? Right? The sum of digits. Can you see that this is divisible by 9? Can I say that this n congruent to Sn mod 9? This n is congruent to Sn mod 9. Start from the first lecture, Shubham. That is how you will know what is mod. You will understand mod. Okay. 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 So, question. Find S of S of S of S of S of 2 to the power 1. Let's assume that this is asked. Right? S of S of S. Right? 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 Now, what is happening here? Let me write a big number for you. 2, 3, 6, 7. Okay. So, what is the sum of digit here? 2 plus 3, 5. 5 plus 6, 7. 7 plus 18, 20. So, can you see Sn is congruent to 8? Now, what is S of Sn? Is it coming out to be 8? Is it coming out to be 8? So, if we apply S multiple times, it actually converges to remainder mod. Converges to remainder. So, this is what we are going to do. What is 2 to the power 1990? Can I write it as what is 59? 1 minus. So, 2 to the power 6 power in 8. 2 to the power 19. The answer will eventually converge to 7. Right? This is live, guys. This is live. This is live. Am I making sense, guys? right? Hello. So what is the proof? Converges like that, right? See, it is very simple. S of n is congruent to n. S of Sn will be congruent to Sn. Take my point? All of these will leave same remainder. All of these, right? All of these leave, right? So how will we know if Sn is very good? This is a very good question. That is why I have written sufficient number of n. How we know? Let me tell you. Let me tell you. So basically, 2 to the power 1990 is less than 10 to the power 1990, right? 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 Obviously, right? So this is a 1990. So the max sum of digit can be when all these are 9, 1990 times. So this becomes 1990 into 9, right? So let's just take it 18,000. So the max SN is 18,000. And in fact, let us write 1700 so that I can maximize the sum of. If you just simply write the sum of digit of this becomes already is in. If you apply S2 or 3 times, this number will become 2 digit or 3 digit. If you keep on if you keep on applying S of n, you get this, right? 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 Okay. Okay. Find if n is 4 digit number such that of n 7, find all possible values of S of n plus S of n plus, right? Can you find it? Can you find it? Sir, I have studied this, but up nice. So let us approach this problem. Now, is a 4 digit number. So one way that it is something something, and it has, let's say, till 5. till 5 here. If you add 4 in it, this simply becomes 9 and these 3 digits remain the same. So in this case, your SN, in this case, your SN 15. But if it is something like 6 and you add 4 here, now this cannot be 9. Can max be 4. Can max be 4. In this case, you have 1 here. Right? So whatever was the sum of digit, which was 5 of, you add 1 here. So you get 5. The sum of digits become, these are the only two options. These are the only two options. 6 and 15. There is no other possibility. There is no other possibility. No. Can only be 6 and can only be 6 and can only be 6 and 50. Right? So a similar type of problem came in IOQM. You saw IOQM 2020. A similar type of problem came in IOQM. Right? So this is all I have for this lecture. I hope you liked it. If you do like it, please do share it. These lectures in English are for the learners who are not comfortable in English. Right? For all the Hindi audience, we have so much content available across YouTube. But this is what I wanted to do for the English audience. Right? I hope you like it. If you do like it, please do share it. Sir, but 1,999 equals n. See, like in this case, your SN will not be 11. No? Your SN will not be 11. You have to take this thing into the account that SN. Right? Okay, bye-bye.